North Augusta, South Carolina, early January 1970. A rigging foreman stands on a purpose-built barge landing on the Savannah River, watching a 175-ton object come the last few feet by water toward a custom-built platform waiting to receive it. 240 wheels, two 600-horsepower tractors. A machine assembled specifically because no standard heavy-haul trailer in the country could carry what was about to be set onto it. The object is a nuclear reactor pressure vessel, manufactured at Babcock & Wilcox's plant in Mount Vernon, Indiana, and it has already traveled roughly 850 miles by barge down the Ohio River, down the Mississippi, out through the Gulf of Mexico, up the Florida Barge Canal, along the Intracoastal Waterway, and finally up the Savannah River to this exact landing. What remains is the shortest leg by distance and the hardest by precision, 145 miles of overland route to Duke Power's Oconee Nuclear Station, the vessel destined for a containment building where it will spend the next half-century generating power. The foreman's crew has one job left in a journey that has already taken weeks: get the heaviest single component ever moved to a U.S. nuclear construction site off this barge, onto that trailer, and onto the road without the kind of error that no amount of remaining schedule could absorb. Before we continue, if this kind of documentation is what you've been looking for, consider subscribing. Every video on this channel goes into one specific element of heavy-haul trucking in America between 1945 and 1995, what a specific transformer, bridge girder, or oil field haul actually required, what the engineers, drivers, and escort crews had to calculate and execute, and what those loads actually became once delivered: the power plants, the bridges, the refineries that quietly ran the country, not spectacle about big trucks, the documented technical reality of a high-stakes logistics trade. What this specific vessel's move actually shows is that the hardest part of building 1970s America's nuclear plants often wasn't the reactor engineering it, was simply getting a piece that heavy from a factory to a construction site at all. And if someone in your family worked in heavy-haul trucking, barge transport, or nuclear plant construction in this era, put it in the comments. What do you remember them saying about it? There's more of this specific supply chain still to come, including the one bridge on this entire 2,000-mile route that the vessel never actually crossed. Back to the road. To understand why this move required a barge, a 240-wheel trailer, and 55 days rather than a single truck and a single afternoon, you need to understand where the vessel came from. Babcock & Wilcox built its Mount Vernon, Indiana plant specifically on the Ohio River, not for convenience, but because a plant manufacturing 175-ton steel pressure vessels needed direct barge access from its own loading dock. There was no other practical way to move something that size off the property at all. The vessel itself was empty of fuel and internals for this journey, and still weighed 175 tons, a single forged and welded steel component built to contain a nuclear reaction for decades, tested to standards that left almost no margin for transportation dent or deformation nobody would notice until startup. Every mile of this route, water and road both, was chosen around one governing fact: this object could not be damaged, could not be rushed, and could not be handled by anything built for ordinary industrial freight. Once the vessel came off the barge at North Augusta and onto its trailer, the nature of the challenge changed completely. On the water, the risk had been about buoyancy, mooring, and cargo securing across thousands of miles of open river and coastal waterway. On the road, for the final 145-mile stretch to Oconee, the risk was about something much more immediate: 175 tons of irreplaceable steel, moving at a maximum of 5 miles per hour on 240 wheels, with two 600-horsepower tractors that had to stay in constant, precise coordination with each other to keep the load balanced and moving in a straight line. This was not a job for a single driver's individual skill in the way a fast highway haul might be. It required a rotating crew of 10 drivers working in shifts across the length of the route, because the job demanded sustained, unbroken concentration at a crawl, watching wheel alignment, watching the trailer's response to the crown of the road, watching for anything that might force a sudden correction on a load that could not make sudden corrections. At 5 miles an hour, a 145-mile route takes days, not hours, even before accounting for the obstacle that no amount of careful driving alone could solve. Somewhere along that 145-mile overland route, near North Augusta, the planners ran into an obstacle that 10 skilled drivers and 2 powerful tractors could not simply drive through: a highway bridge over Stevens Creek that was not rated to carry anything close to 175 tons plus the weight of its own trailer. This was not a case of finding a longer detour to a stronger bridge in this specific stretch of the route. There wasn't one available that solved the problem. The solution the planners settled on was to leave the road entirely at that one obstacle. A custom-built set of portable barges and ramps was assembled specifically to float the vessel across Stevens Creek by water, the same method that had carried it the first 850 miles, deployed here as a one-time fix for a single crossing that the highway system simply could not accommodate. To make that crossing work, crews had to physically cut an island in the middle of the stream in half, carving a straight channel so the barge could move directly from one bank to the other without maneuvering around an obstruction that would have made the float impossible to control. It is a small, strange detail in the middle of an enormous operation, a road move that, at its single hardest point, briefly stopped being a road move at all. Step back far enough, and the entire 2,000-mile journey reveals its actual logic. This was never one mode of transportation solving one long problem. It was 4 distinct systems: ocean-capable barge transit down the Ohio and Mississippi, coastal and canal transit through the Gulf and the Florida Barge Canal, inland waterway transit up the Intracoastal and the Savannah River, and overland heavy-haul trucking for the final approach, each one selected because it was the only system capable of handling that specific stretch of the route, and each handoff between them planned around the physical limits of the leg that came next. The Florida Barge Canal and the Intracoastal Waterway could carry the vessel's weight and bulk in a way no highway system could, but they could not get it anywhere near Oconee's inland construction site. The overland trailer could reach the site directly, but it could never have carried the vessel the full 2,000 miles at 5 miles an hour without turning a 2-month delivery into a project unto itself. The specific landing at North Augusta existed because it was the furthest point upriver a loaded barge of this size could reasonably reach, and the closest point to Oconee that still gave the overland crew a route within reach of 145 miles rather than several hundred. Every leg of this move was chosen not for convenience, but because it was the only physically possible way to get a 175-ton object that far. To understand why a move like this happened at all in 1970, you need to understand what post-war electricity demand was doing to American utilities in this period. Duke Power broke ground on Oconee's 3-unit site in 1967, part of a wave of nuclear plant construction across the country driven by electricity consumption that was climbing at a pace conventional coal and hydro capacity increasingly struggled to match. Every one of those new nuclear plants needed the same category of impossible object delivered to a construction site that was, almost by definition, nowhere near a major manufacturing center. A reactor pressure vessel too large and too heavy to be built anywhere close to where it would actually operate, because the specialized forging, welding, and heavy lift capacity required to build one existed in only a handful of plants in the entire country. Plants like Babcock and Wilcox's Mount Vernon facility, built specifically for this purpose and positioned specifically for river access. This is the part of the nuclear build-out that rarely gets discussed alongside reactor design and containment engineering. The entire industry's growth was gated, in a very literal sense, by how many of these vessels a handful of heavy industrial plants could fabricate and physically ship in a given year, and by whether the logistics existed to move each one the hundreds or thousands of miles from foundry to foundation. When the vessel was finally set into place at Oconee on February 8, 1970, 55 days and 5 hours after it had left Indiana, it was set inside a containment building large enough to make the 175-ton object that had taken 2 months to arrive look almost small by comparison. That scale difference is worth sitting with. Everything documented in this video, every mile of barge transit, every rotating driver, every custom piece of rigging built for a single crossing of a single creek, existed to deliver one component into a structure built to dwarf it. And this was only the first of 3. Oconee second and third reactor vessels arrived in 1970 and 1971, meaning the entire logistics operation, the barge route, the North Augusta landing, the 240-wheel trailer, the Stevens Creek workaround had to be repeated, with variations twice more before the plant was complete. Unit 1 went commercial on July 16, 1973, and Oconee has gone on to become one of the longest continuously operating nuclear stations in the country, still running more than half a century after a plane load of documentation and a barge load of steel first made their way down the Ohio River. The vessel that took 2 months and 10 drivers to deliver has, since 1973, quietly generated carbon-free electricity. Every day it has operated, a fact almost nobody who benefits from it has any reason to know, began with a 5-mile-an-hour crawl through South Carolina. If this channel is going to keep documenting what it actually took to move America's heaviest industrial loads before digital systems took over part of the job, subscribe. There are more transformer holes, more bridge crossings calculated to the ton, more improvised solutions like the Stevens Creek barge crossing, and more of the specific people who coordinated them, who were rarely described as remarkable at the time because delivering the load correctly was simply the job. Whether or not anyone in your family worked on this specific move, what it shows is that America's entire nuclear build-out depended as much on heavy-haul logistics as it did on reactor engineering itself, a fact easy to forget once the plant is running quietly and the trucks are long gone. And if you have a connection, a relative who worked in nuclear plant construction, heavy-haul trucking, or barge transport in this era, put it in the comments. What do you know about what that work actually demanded of them? There's more of this specific industrial world still to document, including what changed when later reactor vessel moves, including recent decommissioning hauls, stopped needing a barge at all. The Oconee vessel's custom 240-wheel rig completed its last mile in February 1970. An improvised platform built essentially once for this specific job because nothing standard existed that could do it. By the time later utilities needed to move reactor vessels of their own, including, decades later, the vessels coming back out of decommissioned plants, the industry had 36-axle Schnabel rail cars and hydraulic platform trailers with hundreds of tires as standard, purpose-built equipment. Direct engineering descendants of the improvised rig that got this vessel to North Augusta. What the modern equipment gave the industry: standardized capacity, faster turnaround, and route planning that no longer had to be invented from scratch for every single move. What it did not need to solve twice: the specific, improvised judgment that had built a barge crossing for a single creek, because the highway system simply had nothing else to offer, the kind of solution that existed only because a rigging foreman and a construction team looked at an inadequate bridge and built their own way around it, on the spot, with the tools of 1970. The foreman at North Augusta did not know that the platform his crew loaded that day would become, in effect, a prototype. He knew only that the vessel had to reach Oconee and that the road, this one time, did not go all the way there. The creek had asked something the highway could not answer. The barge had been the answer nobody needed to invent twice.